Hello students, in this session we will look into the chapter of units and measurements. We need around 3 sessions to complete this chapter. Fine. In the first session, which means in this session, we will see what is meant by fundamental units. There are like 7 fundamental units which you should know. We will do all those 7 fundamental units. Same way you have exceptions to it. Like there are 2 exceptions which is like angle and then the solid angle, right? We will do that one also. From these fundamental units, we will be able to do rest all other derived units in the physics, okay? So we will see all those things. Same way we will see relationship between radian and then the degree, right? From the angle part that we have studied, we will see that relation. So those are something that we will see related to fundamental units. Then we will see what is meant by area and then the volume. From the lower grades that we have already studied, we know how to measure area and then the volume. That is something that we have already known. The thing that we are going to see here is an intuition and the logic behind that area and then the volume. Some students might have already known that one. That is not a problem. For someone who doesn't know, you should know this intuition because we will build differentiation in the next chapter based on this intuition, right? So you should know that intuition behind area and then the volume. We will see that one also. Then finally, we will do parallax method. So parallax method is actually an application of the angle that we have studied, right? So we will see that one. The final part that we will see in the session will be like errors. So while doing in physics experiment, you will all obviously have errors into it, right? So in order to overcome that error, what all are the steps that we can take? So we will see that one. Same way, you'll have to do experiment n number of times and then you'll have to take an average out of it, which is called as a mean. We will find that one also. And then to calculate error, we will find like del a mean. We will do like what is meant by relative error, absolute error, and all those things will be done in this session, right? So those are something that we will see in this session. In next session, we will do the second part of this chapter. The second part of this chapter is going to be like propagation of error. How does an error flow as you do like addition, multiplication, subtraction, and division while doing arithmetic operation? How does an error propagate? We'll see that one. Then we will see what is meant by significant figure. Next session, these are something that we will see in the next session. And then the final part that we will see is like dimension analysis, right? All those things will be done in the next session, right? So third session that I've mentioned is going to be an extras part, right? So this is the syllabus that we have in NCERT. So the in extras part, what we will do is like vernier caliper and screw gauge. These two things, vernier caliper and screw gauge, are not in the NCERT, but still you get question from vernier caliper and screw gauge. So we will do that one, vernier caliper and screw gauge, how to find the reading, and all those things will be done as an extras part in the third session. Okay, so these all are something that you should know in this chapter, right? So let's jump into it. The first one that we will see is like fundamental units, right? So fundamental units, in that fundamental units, first 3 units are something that you already know: length, mass, and time. Okay, so in order to measure length, what we do is we use the convention for as meter. Meter is something that we use to measure the length. There are like other convention, foot, we could measure in foot, but that is not an SI unit. SI actually means standard international unit. So in standard international unit, in order to measure length, we use unit called meter, right? So that is the fundamental unit for length. Same way for mass, we will use like kilogram to measure it. Okay, and then for time, we use seconds to measure it. Okay, so these are the SI units. Okay, that should be known. There was clash when people use different units in different countries. Okay, let's say for example, foot, pound, second was used in some country as their convention, and same way meter, kilogram, second, as I have given here, this one was also used in some countries. So when physicists were doing experiments, they were measuring units in different standards, right? So in that situation, you'll get different constant value. So in order to overcome that one, we fixed a standard international unit. So whenever you do an experiment, you will have to measure a constant by using this standard international units, right? So length, in order to measure length, mass, and time, we use meter, kilogram, and seconds, right? This is something easy. Then we have like luminous intensity. So in order to measure the brightness of a light, as the name suggests, luminous means light, intensity means brightness, right? To measure the brightness of light, the unit that we are going to use is like candela, 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 and the symbol for this one is CD. Okay, we will write this one in small letters because this is not the name of the scientist. Okay, if it was a name of a scientist, we will write it in capital letter. As it is not a name of a scientist, we will write it in small letter. This unit will not be used much in the upcoming chapters. Okay, in the 11th and 12th grade syllabus, we will not use this unit at all, but you should know in order to measure luminous intensity, the unit that we are about to use is like candela. Okay, this is something that you should know. Next comes current. Current actually means flow of charge in the given time. So what is the charge that is flowing in the cross sectional area in a given time is called as current, right? Okay, so in order to measure current, you will have to divide charge divided by the time. That will give me the current. So the unit for charge is actually coulomb. So either you could take coulomb as an SI unit, or you could take ampere current as an SI unit. In this situation, I took current as my fundamental unit. So in order to get the unit for the current, I'll consider it to be an ampere, where ampere is the name of the scientist. Therefore, I'll write it in capital letter. Okay, I could either consider coulomb. So here in this situation, if I have to get the unit for coulomb, unit for charge, what I will do is that's going to be ampere times second. We'll do the cross multiplication. So that is called as derived units, right? We will do that one. Okay, as we see multiple formulas in the upcoming chapters, you'll get to know what all are the units that you need to know. Okay, right? As you know the formulas, you will obviously get to know those units also. So here for current, the unit is ampere. Okay, A-M-P-E-R-E. So ampere is name of a scientist. Therefore, I'll write it in capital letter, which is like capital A. Then comes the amount of substance. So in order to measure the amount of substance, we will quantify a number to it, right? Let's say, for example, let's consider 1 dozen. 1 dozen actually means 12, right? If I'm going to tell you 1 dozen of eggs, which means 12 eggs, right? If I tell you like 1 dozen of chair, it means 12 chairs. Same way, if I tell you like 1 dozen of cars, it means 12 cars. That's it, finish. So 1 dozen actually represent 12. That's what it represents. It doesn't represent the object that you are about to take. So same thing here. For amount of substance, I'm going to fix a number which is called as mole, right? The unit is like mole. The number that I am about to choose for mole is actually 6.023 into 10 power 23. Fine. This is such a huge number that I have taken because while doing experiment in a microscopic level, what we do is we actually calculate all those number of atoms, right? So when you calculate all those number of atoms, it's such a huge thing. Fine. So in order to do things in a macroscopic level, I'll have to consider a huge number. That is why I've taken a huge number here. So the reason why I took such a huge number, the logic behind this one is you take 12 gram of carbon atom and then count number of atoms into it, right? So it could be easily counted because I know the mass of one carbon atom. So from the mass of one carbon atom, the mass taken divided by the mass of one carbon atom, which is like 12 gram that I've taken here, divided by the mass of one carbon atom gives me the number of atoms. Okay, so anyway, here what I have done is I took like 12 carbon atoms, 12 gram of carbon atoms, and then I counted number of atoms into it. When I counted number of atoms into it, I got the answer to be 6.023 into 10 power 23. The reason why I considered 12 gram of carbon atom is because while doing experiments, physics or chemistry experiments, whatever it is, if you have to take a carbon atom, it should be measured in grams, right? You can't take 12 numbers of carbon atom or something like that, 12 carbon atoms. Okay, so you'll have to take it in a macroscopic level. Therefore gram makes sense, so I took it in 12 gram of carbon atom, right? The reason I specifically took 12, that number 12 gram, is because in carbon atom you have like 12 nucleons, which means 6 protons and then the 6 neutrons. Therefore for a carbon atom you will have like 12 nucleons, right? So that 12 gram has like 6 into 10 power 23 atoms, which is equal to 1 mole in this situation. Same way, if I consider hydrogen, which has just 1 nucleon, which is going to be like 1 proton, in that situation, in order to match the number of atoms with carbon and then the hydrogen, I should take hydrogen as 1 gram because you have just 1 nucleon, right? In order for that similarity, I took it in such a fashion like 12 gram of carbon atom, right? We will do this one exhaustively in chemistry. As if now what you should know is for amount of substance, I will measure in mole. That 1 mole is such a huge number, which is going to be 6.023 into 10 power 23. Next one is temperature. In order to measure temperature, multiple scales could be used. Celsius scale can be used, or else Fahrenheit, Kelvin scale could be used, right? There are other scales also, but these three scales predominantly come into picture, right? Out of that, Celsius and then Kelvin scale is something that we use quite often in physics, right? So Celsius scale, this is based on the behavior of the water, right? The freezing point of water will be considered as 0, and then the boiling point of water will be considered as 100. we'll split equal divisions, 100 divisions in between. So we'll get that Celsius scale, right? So that is how Celsius scale is built. So it is built on the happening of the water, right? So that couldn't be considered as an absolute scale. Therefore, we'll have an experiment that we will do in thermodynamics. From that, you will get to an intuition. So based on the behavior of gases, whatever gas you take, you will have some similar behavior. From that, we will derive the Kelvin scale. So that Kelvin scale will be my absolute scale. Therefore, for fundamental units, for temperature, I'll consider Kelvin as my SI units, right? So Kelvin should be considered here. In Kelvin, Kelvin is name of a scientist, therefore I'll represent it by capital K. Fine. So SI unit for temperature is actually Kelvin. Fine. So Kelvin scale is an absolute scale. I'll give you one logic to it. In Celsius scale, what I could do is I will be able to get -1 degree Celsius, -2 degree Celsius. That is possible in the Celsius scale. Whereas in the Kelvin scale, I can't go like -1 Kelvin or -2 Kelvin. That is not possible. 0 Kelvin is the lowest temperature that we could actually reach. Therefore, this scale is considered as Kelvin scale, right? We will see the logic and all those things in the thermodynamics chapter, which we'll do in the second part, okay, second volume, right? As if now what you should know is, in order to measure a temperature, the SI unit is going to be Kelvin, right? So these all are the 7 fundamental units that you should know. Length, mass and time is something that we have known from the lower grade itself. Then comes the luminous intensity. So luminous intensity is the measure of brightness of the light, okay, candela. We don't use this unit in 11th and 12th standard. Anyway, you should know this name. That is something that should be known. Then comes current. So current is actually the flow of charge per second. So I'll consider current as my fundamental unit, and the unit is going to be ampere A, right? So then next one is like amount of substance. So in order to measure an amount of substance in a microscopic way, and then to compare it with the real time happenings or the macroscopic things, what I should consider is I'll have to consider such a huge number. That number is going to be 6.023 into 10 power 23. This consideration is got from the carbon atom, 12 gram of carbon atom, right? That too should be known. Then comes temperature. To measure temperature, we use Kelvin scale. Fine. So these are the 7 fundamental units. Then comes the exceptions part into it, which is like the first one, that is going to be angle. The unit that we are about to give for angle is radian. Radian, or the symbol that will be rad. Okay. You need to know this one. In order to get the logic behind the angle, what we do is we consider here two circles. First circle will be the smaller circle, and the same way we'll consider a bigger circle. So there are two circles which we consider, okay? And what we do is we make an angle theta with respect to both those circles. So in this situation, from the origin, initially for a smaller circle, I consider the radius to be r1. Same way for a bigger circle, I consider the radius to be r2. So we consider two radius in this situation. For the smaller one, it is like r1, and for the bigger circle, it is like r2, right? And then it sweeps an angle theta with respect to both those circles from the origin. So when it makes an same angle theta with respect to the origin. So in this situation, if I have to fix a constant value irrespective of the size of the circle, what should I do, right? How should I take the ratios, or should I multiply in certain fashion so that I have the same value for this theta, right? So I'll have to get an intuitive thinking behind it, right? So we did make an equivalent portion in with respect to both those circles, smaller circle and then the bigger circle. Then comes the angle theta. So in order to give a particular number to it, how should I do a mathematical calculations to it, right? That is what we are going to get. So in this situation, if I just only consider radius r1 and r2, those two are obviously not same. Same way, if I consider this arc length or the curvy distance, let's make it this way. For a smaller circle, let's consider that distance to be s1, okay? And for a bigger circle, I'll consider that distance to be like s2, that arc length to be s2. If I consider it in that fashion, obviously s1 is not equal to s2. It is pretty clear. S2 will be greater when compared to S1, right? So from the diagram itself, it is clear S2 is greater than the S1. So in this situation, I will not be able to match S2, S1 directly to get that angle theta for the same value, or R1 and R2. But the thing is, if I take a ratio, then both those values will be same, right? So if I need to get a constant value for this theta, because both has swept same angle for both the circle, right? For smaller one and the bigger one. So in that situation, this theta has to be constant. Then I'll have to take a ratios of that arc length divided by radius. If I do that one, then theta will be same irrespective of the circle, okay? It could be a smaller circle or the bigger circle, still you will get the same theta, right? So to make this theta a constant value, what I do is I take the ratios. So when I do take the ratios S1 divided by R1, I get the same value which is equal to S2 divided by R2, right? If I consider unit in this situation, for S1 the unit will be meters, and then for radius the unit will be meters, right? From the fundamental units, if I substitute that unit, I'll have the same units again repeated, right? So it seems it gets cancelled out, and then the situation seems to be like no unit case. But if I consider theta to be no unit 1, then this thing comes up again and again in physics, right? So in that situation, I'll not be able to consider theta as an no unit case. Therefore, I'm going to specify a unit to it. That unit is called as radian. Okay, so this is kind of a special case. That way I put it under the category of exception, right? You should be able to understand this one. So here what I do is I'm going to fix this one for half the circle, which means for semicircle I'm going to fix pi, which is an irrational number. We'll do that one. So for a smaller circle, for half the circle, which means for semicircle, in this situation I'll consider this arc length to be S1 dash and then S2 dash. Okay, I'll consider this one like S1 dash and then S2 dash. So obviously for S1 dash divided by R1 should be equal to S2 dash divided by R2, right? So theta dash will be equal to S1 dash divided by R1, which is equal to S2 dash divided by R2. Okay, these two things should be equal. So I'll consider this number to be pi. Okay, so I'll consider that number to be pi. Pi is considered as an irrational number, right? I'll tell you the reason. The reason is because rational number or something that I'll be able to match with the whole numbers that I have. Okay, fractions that I have, I'll be able to match with that number. Then those numbers are called as rational numbers, right? So in this situation, if I have to get an exact value of this pi, what I should actually do is I'll have to do this experiment as precise as possible or as accurate as possible. For example, in order to measure that arc length, let's make it this way. I keep thread to measure that arc length. Then I'll have to stretch it and I'll have to measure the length of the thread as exact as possible, which means I'll have to find all those decimal places in order to get the exact value of this pi. But that thing is not possible, because the more decimal place you get, the more correct answer you will be able to get. But in real time situation, I'll have to match it with the real numbers that I have, right? So the number that I'm going to choose is going to be like 22/7. So that number will be closest equivalent to the pi, right? So that's the fraction that I'm about to take, which is like 22/7. So in the sum, either I'll be able to substitute 22 divided by 7 or I'll substitute 3.14. So both those things are possible. So here this thing, which is like pi, is considered as irrational number, because the more accurate you do the experiment, the more correct value you will get. So the closest value that I could match with will be like 22/7. So that is what I have given here, right? So these are understanding that you should know. So you should know what is meant by irrational number, fine. So irrational number is something that is like an experimentally derived quantity. Same way you have another one irrational number, you have multiple things. The other one best example is like E. We will get that one from the differentiation. So more exactly you find that slope, the correct answer will get that for E, right? So differentiation of E power x will be equal to E power x. So we will see all those formulas that you need to know. And by the way, we don't see the proof into it. The thing is, we will see outline of the understanding behind the differentiation in the next chapter, right? So E is also an irrational number, because the more exact you find the slope of that curve, the more exact value of E you will be able to get, something like that, right? Okay, same intuition behind this pi. So you will have the same logic for that E also. Then comes for full circle. So in order for a full circle, I'll have to measure the circumference of a circle, right? So circumference of a circle is actually like a perimeter of that circle, right? So to get that perimeter of a circle or circumference of a circle, I'll use this theta logic, angle logic itself, to get that answer. So for a full circle, how should it be? For a full circle, the theta that I swept is like 2 pi, right? For a semicircle, if it was equal to pi, then for a full circle, the theta that I would have swept will be equal to 2 pi, right? So 2 pi equals arc length divided by the radius. So arc length is like S, and then divided by the radius is R in this situation. So this arc length in this situation for a full circle is called as circumference of a circle, right? So circumference of a circle will be equal to 2 pi r. So that should be equal to the circumference of the circle. So these all are the things that you should know regarding the angle. Fine. So now we are clear with what is meant by radian. Next, what we will see is the relation between the degree and then the radian that we have seen here. Same way, the degree is something that we have known already from the lower grade itself. Circle comprises of 360 degree, right? Those things we know. So we already know degree clearly. So now what we are about to do is we will match the relation between degree and then the radian, right? So we'll see that one. Relation between degree and radian. Here I consider two circles, the smaller one and the bigger one as usual. What I'm about to do here is I'll cut this circle into 360 equal slices, okay? So when I cut this one into 360 equal slices, if I put all those 360 slices, I'll get the complete circle again, right? So for degree, generally I'll consider for a complete circle, it's going to be 360 degrees. So that's the convention that we stuck to. So we'll stick to that convention itself. So for degree, it's going to be like 360 degree, right? Got it? Therefore, if I'm asking you to put 4 degree, what you do is you just put 4 slices together. So that will be like 4 degree. This is easy for us to imagine and to understand, right? From the physics perspective, radian makes lots of sense. But for imagination, degree is easy, right? Therefore, what I should do is I'll have to find a relation between degree and then the radian. In this situation, I know like 2 pi equals 360 degree, right? Or else I'll be able to consider pi which is equal to 180 degree. Then the thing that is unknown is for unknown radian, I'll have to find the matching degree. So that is the thing that is unknown here. So that is easy. So if I know like one thing, then in order to get the next part, what I do is I'll be able to put it in ratios and I'll be able to get the answer. We will do that one. Here theta equals pi by 6 radian, right? So if theta equals pi by 6 radian for this one, what should be the degree? That is what I'll have to find out, right? If it was like 10 degree, then I'll be able to put 10 slices and I'll get 10 degree. But I do not know degree in this situation, but the radius is known. Radian is known, right? So radian actually falls from the physics thing, but that is hard for us to imagine. Therefore, I'll have to convert this one to degree for easy understanding, right? So here what I do is one thing is known, which is going to be pi, which is equal to 180 degree. This part is known. Same way, the unknown part here is like pi by 6. That is what I need to find. So what will be the degree for that pi by 6, which is going to be x, right? So I'll put it in ratio logic and I'll get the answer straight away. So here pi, it will get cancelled. So if I do the cross multiplication, what will I get is 180 divided by 6, right? So the here unknown theta will be like 180 degree divided by 6, which is equal to 30 degree. So for radian pi by 6, the theta that I'll get is like 30 degree. So if I get like 30 degree, what I will do, I'll put like 30 piece slices into it. So that will be the radian pi by 6, fine. So pi by 6 is hard for us to imagine, but degree is easy for us to imagine. But degree is something that is easy for us to imagine, but the way radian is something, it comes from the physics logic behind it, right? So in order to cross match that one, we have found this relationship, okay? So this is something that you need to know. So this is like the straight away ratio thing, right? You just put the known values and then the unknown value is going to be x, so you'll get the unknown value x, right? So here same way, for theta equals pi by 4 radian, what should be the degree that I need to get, right? So theta will be equal to, for pi it is equal to 180 degree, right? Then for pi by 2 it will be equal to 90 degree, correct? Then for pi by 4 it will be equal to 45 degree. So straight away the answer will be like 45 degree. Even if you put into this ratio, you'll get the answer to be that one, right? So you should know this one, right? So this is the relation that you need to know between degree and then the radian. Next comes the intuition between area and then the volume. Fine. So in the first case, I have considered the area such that the length will be equal to 1 meter and the breadth is equal to 1 meter. Fine. The formula is something that we already know. In order to get an area, what I should do is I'll have to multiply the length times the breadth, right? So length is like 1 meter in this situation, breadth is also 1 meter. Therefore, L into B is going to be 1 meter square. Fine. Let's see for the next one. So in the second case, I have like length to be 2 meter and same way breadth to be 1 meter. So in this situation, it is such that if I do the multiplication, the answer will be like 2 meter square, right? So these are something that we have already known. The intuition that you should have here is, if I split this box, I'll have like two 1 meter square boxes into it. Fine. So there are like two 1 meter square boxes into it. That is how you'll have to imagine. So that's the intuition I was talking about. So you should know that intuition, which means it's like two 1 meter square boxes is into this area. That is something that you should know, right? Same way in the third case, you have like 2 into 2, which is going to be like 4 meter square. That actually means you have 4 1 meter square boxes in the given area. Then how will I be able to split that 4 1 meter square boxes? So you have something like this. So this is how you'll split, and then you will have like 4 boxes, 1 2 3 4. So obviously you are having like 4 1 meter square boxes. So whenever I tell you an area to be like 8 6 or whatever number I give you with respect to that unit, if it was like centimeter, it's like 4 centimeter square boxes, you have 4 1 centimeter square boxes you have into it, something like that you'll have to imagine. Okay, so that is what I have given here. So here I have an circle whose area is going to be 3.5 meters square. So what this actually represents is it has 3 full boxes and then 1 half box. That is what it represents. So it represents it has 3 full boxes, which means 3 full 1 meter square box, and then same way it has 1 half box into it. Okay, that is what this represents. So this is how you'll have to imagine area. So same way I'll be able to imagine volume. So here I have like length to be 1 meter, and then the breadth to be 1 meter, and then the height to be 1 meter. Okay, so in order to get the volume of this box, what I will do, I'll do the multiplication between length, breadth, and then the height. Therefore the volume will be equal to 1 meter cube. So that is what I'll get in this situation. The volume of this box is equal to 1 meter cube, right? Fine. So next we'll take the next scenario, which will be like 2 meter length, breadth, and the height. So length here is like 2 meter, and the breadth will be equal to 2 meter, and the height will be equal to 2 meters. So that is how it is here. So if I'm going to consider as 1 meter square boxes, how should I get? So if I do the multiplication, 2 into 2 into 2, 4 times 2 is going to be 8. So you should have like 8 1 meter cube boxes into it, right? The answer here is something that we already know. The answer will be like 8 meter cube. So in order to imagine this one, I need to have like 8 1 meter cube boxes, right? Let's split it. If I split, you will have like front one portion and the behind portion. So in the front portion, you will have like 4 boxes. Same way on the back portion, you will have like 4 boxes, right? So you have like 4 boxes in the front, 1 2 3 4. Same way behind, you have like 4 boxes, 1 2 3 4, right? So we have like 8 1 meter cube boxes. That gives me the volume to be 8 meter cube. Okay, so this is how you'll have to imagine area and then the volume. This is the intuition that I was talking about. You should know this understanding. So from this understanding, you will be able to build up the concept of differentiation and all those things, right? So next we will see solid angle. Solid angle. The symbol that I use to notate solid angle is omega, right? The SI unit here is steradian, and the symbol for that steradian is sterad, right? In the angle, I consider it to be rad. So in this situation, I'll take it as sterad. That's it. The symbol is sterad. Fine. So solid angle is something for a sphere, three-dimensional object. In order to measure the angle for a three-dimensional object, I use solid angle, right? The angle is something that we used for two-dimensional thing. So I took circle over there. Here I'll consider three-dimensional thing, which is going to be sphere. Okay, so whatever logic that we applied there, the same intuition that we'll get here. But the thing is, this is like a three-dimensional object. So here the radius will be like r in the first situation. Same way in the second situation, the radius will be like r dash, which will be the grade for a bigger sphere, and then for a smaller sphere, the radius is going to be like r. So here, what should I take is the area, right? As this is a three-dimensional object, I'll consider the area, the small portion of area in that sphere. Same way, the radius will be like r. So I'll have to divide area by the r in the situation. The previous situation, I divide it by arc length or the arc length divided by the radius. In this situation, I'll have to divide the area divided by the radius. But here, if you see, this is like an area, therefore it's like length times breadth. So if I divide only by area, it will not be symmetrical. So how should I divide? Actually is I'll have to divide by r square, so that I get same answer irrespective of the size of the sphere. Okay, so that is when I'll be able to consider it as an angle, right? So same intuition here. I'll divide the area divided by the radius. Okay, so area divided by r square, that will give me the solid angle omega. Fine, for a smaller circle. If it was a bigger circle, I'll divide something like this: a dash, that bigger area divided by that radius, which will be like r dash square. So in both those situations, you'll have the same omega, because it doesn't depend on the size of the sphere. It actually depends how far you have cut it, right? How far that has swept. That is what it actually depends on, right? So same intuition that we put for two-dimensional object, the same way I'll put the same thing as for three-dimensional thing, right? So here the three-dimensional object that I consider will be like sphere, right? So we should get that intuition and logic behind angle and then the solid angle. We will not do much about solid angle in the physics. Both in 11th and 12th, we won't do much about that one. But angle is something that will pop up again and again in the upcoming chapters, right? The next one that we will see is like parallax method, right? As I've already told you, parallax method is an application of the angle that we have studied, right? So what we find using parallax method is the radius of the exoplanet or the planet that is farther away from the earth, right? Let's take it moon in this situation. So if I have to find the radius of the moon, what I will do is I'll take a telescope, right? So a person here who is standing on the earth, he is having a telescope, and then the telescope has a laser beam attached to it, right? So he points the telescope in such a way the laser beam hits the one end of the moon, right? Okay, and then it returns back. From this situation, I'll mark this as an initial point. Same way, I'll move the telescope to an inclination so that I'll be able to reach the exact opposite end of the moon, right? So I just swept at an angle theta, and then I was able to touch the other end of the moon. So in this situation, the angle theta was swept here, right? This angle theta is known because I was the one who was moving this telescope, right? So here theta is known. The unknown here will be like the distance between the moon and the earth. That is something that is not known in the situation. Same way the radius is not known, right? So here I will get the arc length, but this in this situation the orbit of the moon is considered so huge such that this portion is extremely small. Okay, so I could consider this to be an arc, or else this is so tiny I'll be able to consider this as a straight line itself, right? So this arc length or the straight line will be the diameter of the moon in this situation, right? So now I know the angle theta. So from that, if I need to find this diameter of the moon, what I should do? So diameter of the moon will be equal to S, which is equal to theta times R. So here theta is known because I was the one who was moving the telescope. So theta is known, but in order to get this R is nothing but the distance between the moon and the man who is standing on the earth, right? So that is the distance that I need to know, right? So in order to get that distance, what I do is I send a laser beam from the earth to the moon. So it hits the moon and then it returns back. We know the speed of the light, which will be approximately equal to 3 into 10 power 8, right? So we know the speed of the light. Same way, I was the one who was sending that laser beam. So I could use a stop clock to measure the time. So how long does it take for the light to reach the moon and to return back? From that one, I'll be able to get the time, right? So I know the time and then speed of the light, right? So those two parameters are known. So in order to get the distance, what I should do, the speed is nothing but the distance divided by the time. So time is known if I multiply it with the speed. So time into speed, if I do the multiplication, I'll get the distance, right? So R will also be known. With all those things, I'll be able to calculate the distance between the man who is standing on the earth and then the moon, right? So if I know the distance, in the situation I consider it to be moon. If it was any other star or planet, also I'll be able to find that distance, right? So when distance is also known, and same way the angle swept is also known, if I do the cross multiplication, I'll get the S, the arc length. Okay, so this S will be the diameter of that particular planet. If I want to know the radius, I'll just be able to divide it by 2. The only part which was missing is the distance between the man and that particular planet. In order to get that one, with the velocity of the light, I'll be able to match it such a way. I have a stop clock in my hand, so I'll know the time and then I know the velocity. If I do the multiplication, then I'll get the distance between that particular planet and the person who is standing on the earth surface. Okay, so these are something that could be figured out using parallax method itself, right? So this is the thing that you need to know regarding parallax method. We are into the last part of this session, which will be like error. Whenever you do an experiment, you find a reading, you are obviously going to have error into it. So what all are the errors that you come across? The first one is like systematic error, right? So in systematic error, there are like 3 patterns in which this error could occur. The first one is instrumental error, which means the instrument in it itself is wrongly calibrated or there is some error in that instrument. So I'll have to rectify the instrument to get the correct value, right? So instrument should be corrected to get the correct value, right? So that is called as instrumental error, the simple one. The next one is imperfection in experimental technique. So you do not know how to do that experiment. So you yourself, your knowledge is not good enough to do that experiment. Then in that situation, you'll get the wrong reading, right? So study the experiment well. Imperfection in experimental technique, right? So third one is like the personal error. So personal error means you don't look at the value properly, right? So the reading shows certain value and you do not look at it properly. Then you end up noting down wrong answer. So in that situation, that's the personal error, right? You didn't look the answer correctly. So that is called as personal error. So all those three things could be corrected. That is why it is called a systematic error, right? The second one is random error, which couldn't be corrected because, so this is happening because of many other external parameters that surrounds us, which can't be controlled. Okay. So in that situation, we will come across this random error, right? So end of the day, however accurately you do that experiment, still you will have error into it, right? So in order to overcome that error, what we do is we do the experiment multiple times and take an average out of it, and I'll consider that average value to be my real value. So that is called as a mean, right? We will see that one in the next part. A mean means average of all the values that I have taken while doing an experiment will be the A mean. So here, in order to get the A mean, what I do is I take an average of all the values, which is going to be like A1 plus A2, and then it goes up to the nth experiment that I have done divided by total number of experiment, which is going to be n. So that gives me the A mean, the just average thing that I have done here. So I'll consider that to be my real value, right? If I write that one in short notation, I'll have something like the summation of I equals 1 to n, and inside the summation I'll have like ai, right? And then divided by n. So n is just a common one, therefore I'll be able to factor it out, something like that. So I'll have like 1 by n summation of I equals 1 to n ai, right? So that's the short notation for the above thing that I have written here. Okay, so you should know both those notation. That is what I have given here. So here I will consider a mean to be the real value. Then what I need to find is what all are the error in every experiment that I have done. Okay, in all those single experiment that I have done, I'll have to find the error into it. So in order to get that error, what I do is I subtract a mean minus the value that I have got in that particular experiment. Okay, so that will be something like this: del a1, which will be equal to a mean minus the reading that I have got in the first experiment, which is like a1. Same way for del a2, I'll have like a mean minus a2, and then for del an, I'll have like a mean del a mean minus an. So this is what I'll get in all those instances. So now what I have found is del a1, del a2, and then del a n, right? So this could be either positive or negative depending on the situation. See, this thing that I have taken an average value out of it, so average could be greater for a particular situation or lesser for a particular situation. It depends on the experiment, right? So the del a1 could be like either positive or negative, but the thing is, in order to get an absolute error, that value should be a positive value. Therefore what I do is I take an absolute error out of it. Okay, so absolute error means it's the positive answer for all those things. So I'll take all those negative signs out of it. So to take out all those negative signs out of it, I put a symbol called modulus, which means like two vertical lines, right? That is what I'll put, right? So I have here del a1, del a2, and del a1, del an, which will be my absolute error, right? So here I have found my absolute error. The purpose here is to find the average value out of it, right? So that is why I have took modulus in this situation, because that is when I'll have all the values to be positive, and then I'll be able to extract average value out of it, right? So then what we are going to do is mean absolute error. So mean absolute error, as the name suggests, we are going to take average out of the absolute errors that we have found, right? So mean absolute error will be represented as del am, which will be the average. That's going to be modulus of del a1 plus modulus of del a2 up to modulus of del an divided by the total n number of experiments that has been done, right? So here, if I have to write this one with the short notation, it will be like summation of I equals 1 to n, and then you'll have like ai modulus of del ai, right? Modulus of del ai, and then 1 by n could be written outside the summation. So this is what you'll have as a short notation, right? Which will be mean absolute error in this situation. So now what I have found is I have found the two things. One is like mean value, okay, a mean, and then I also have found mean absolute error, which will be like del a mean. So the thing here is I found the real value, which is the average value here, that I'll consider it to be a real value. Same way, the error deviation that I could have is like mean absolute error, which will be like del A mean. So these two things are something that I found here. In the next page, we will do how to consider this in a real-time situation is something that we'll do next. As if now what you need to know is like what is meant by del A mean, same way what is meant by A mean, right? From these two things, what I'll be able to get is like relative error and then the percentage error. So relative error is something that is related to unity. So as the name suggests, we'll do like a relative thing, right? So in the numerator, I'll put del A mean, same way in the denominator, you'll have like A mean, fine? So in the numerator, you have del A mean divided by del A mean is the error in the measured value. Same way, the real value will be like A mean. So this is how we'll have to find the relative error. So this is something like the total value is considered to be A mean and then the error in it will be put in the numerator. Fine. So with respect to unity, I'm just finding out the answer here. So in the numerator, you actually had mean absolute error and in the denominator you had like mean value. Okay, when you take ratios out of it, you get the relative error, right? So you have like mean value, right? Next, what I'm going to do with this one is like to find the percentage error. So to get the percentage error, what I should do, I'll have to multiply into 100 with the relative error. That is what I've done in the next step, which will be like multiply it with 100, you get the percentage error, right? So with respect to unity, I consider it to be relative error. Same way with respect to 100, it is obviously a percentage error. Fine. So these are something that you need to know. So these relative errors and percentage error will come into play while doing propagation of errors with respect to multiplication and division, right? So these are the things that you should know. Same way in the situation, I have used variables in every single case. In the next part, I'll use numbers. Okay, so when I put in numbers, you'll have logical understanding to it. Here I consider a rod whose length is unknown, right? So now I'll have to measure the length of the rod. So I do experiment 4 times and I get like 4 different values out of it, right? So to make things simple, I took length of the rod, right? It could be like any physics experiment that you do, right? So in the first situation, I got the answer to be 4, right? While measuring the length of the rod, in the first case, I got the answer 4. Same way, I did the experiment again and I got the answer to be like 4.1. I repeated it again and I got the answer to be like 3.9. And then repeating it again gave me the answer 4, right? So randomly I chose like 4 different values, right? Okay. So what I have to do with the 4 values, I'll have to find the A mean from this 4 different value. Same way, I'll have to find the del A mean, which means the error with this 4 value. Okay. So in order to get the error, what I should know is del A1. Okay. Absolute error is something that I need to know in every single case. So in the first case, in order to get the absolute error, I'll have to find A mean initially. So to get A mean, what I do is I'll have to consider all those values divided by the number of experiments that I have done. So the values are like 4 plus 4.1 plus 3.9 plus 4, right? Then I'll have to divide it by the number of experiments that I have done. That's going to be 4, right? So when I take an average out of it, the value will be like in this situation, this is like a simple case, fine. So I got the answer to be 4. Okay, so the A mean here is 4. Now I have got the length of the rod, which is the real value, that's going to be 4. So the first thing is done. So the length of the rod is going to be like 4 meter, which is the A mean in this situation. Okay. So next what I'll have to find is I'll have to find the del A1, del A2, del A3, del A4 in all those situations. So that's going to be A mean minus A1 and the modulus, right? So A mean minus A1 will be like 4 minus 4, which is going to be 0 in the first case. In the second case, it will be like 4 minus 4.1. That's going to be 0.1 because modulus, therefore it's going to be positive 0.1. In the third case also, it's going to be 0.1. In the fourth case, it's going to be 0. Okay, so now I have found all those del A1, del A2, del A3, those situation. Then what I should do is I'll have to find del A mean, right? So del A mean will be considered as error in the particular measurements that I have done, right? So del A mean will be like summation of all those things divided by the number of experiments. So it's going to be 0 plus 0.1 plus 0.1 plus 0 divided by 4. So here it will be like 0.2 divided by 4. That will be like 0.20, right? 0.20 by 4 will be like 0.05 meter. Okay. So now I have got the error in that measurement. Fine. So the length of the rod should be written something like this. So when I write the length of the rod in physics term, I'll write it something like this: 4 plus or minus 0.05 meter. So how I should interpret this one is actually, if I give this rod to someone and then if he is measuring and value between this range, then the answer is correct. For example, he could tell the length of the rod to be 4 point below 4.05 or it should be above 3.95. That's the range he could actually give, right? So if he gets an value that is between 3.95 to 4.05, then the measurement that he has done with this rod is correct. Okay, that is what this represents. Let's say, for example, you go to a shop and then you get a resistance, okay, and the value that you have put over there is like 100 plus or minus 15 ohm, right? So ohm is actually unit of resistance, right? So here if they have put 100 plus or minus 15 ohm, this represents that resistor that you have got could be between 100 minus 15, which is like 85 ohm, to 100 plus 15, 115 ohm. So the resistance that you have got could be between these extremes. That is what they have given there. Okay, so whenever you have a physics experiment that is done, so the final answer, the way we write is, you will find a mean value out of it, and the same way you'll have like plus or minus that deviation. So that deviation is considered to be the error. So if someone else is going to do that experiment and if they got the value in between that range, then he has done that experiment correct. Okay, so that is how we do experiments in physics. Okay, so this is something that should be not fine. So what are all the things that we have seen in this session is actually fundamental units. We saw what is meant by fundamental units. Same way we saw exceptions into it. Those exceptions are actually solid angle and then the angle, right? In angle we found the relation between degree and the radian. From physics understanding we got radian. That is actually hard for us for imagination, so we put degree into it. So degree was easy for us to imagine, and then we found a relation between degree and then the radian, right? The next thing that we saw is like area and then the volume and the logic behind it. Okay, so that is something that was easy. So then we saw parallax method, right? So parallax method is the extension, is the application of the degree that we have seen, right? So the last part that we saw was errors. How does an error happen in an experiment? That is something that we saw. Then we saw how to take an average value out of it, which is like a mean. Same way we saw del a mean, which is the error in it, right? So with that we complete this session. Fine, so rest of that part will be dealt in the next session. With this the video gets completed. Bye.